Hello guys, this is going to be a walkthrough of a couple of the files that we're going to use in order to make a card game. So I'm providing the deck class, this is deck.java, and the card class among a few other things. And we're going to spend most of our time looking at these two files. So let's start by looking at the deck. Deck has one private data member, an array list of card types called deck. When there's one constructor that just initializes that array list. There's also a static or a class side method that returns a deck object. So there's a static method that returns a deck object, and it creates a full deck. So what this will do is it'll create 13 of each of the different suits of cards using the card constructor. So when you want to have a standard deck of 52 cards, you call this method, and it will return it for you. There is a method that adds all the cards of a deck. So give me a deck, and I will put them into my deck. There is an add method that takes in a single card. So this is called an overload of the add method. There are two ways to add. So we say that that method is overloaded, and the program will make a distinction as to which of the methods to use based on the parameter that comes in. If you hand a card to me, I will use this add method, and if you hand a deck to me, I'll use this add method. We also have two overloaded deal methods. One deal method says give me a number and I will deal a deck of that many cards. Another deal method has no parameters and just returns a single card, and it will give you the card at the top. There is also a get method that returns a card from the deck but does not remove it from the deck. There is a clear method that empties everything out of the deck. A size method that tells you how big the deck is. And we're going to skip these two for a second to come back to them. There is a toString method that prints the deck. And all these methods that we just went through have extensive documentation and comments explaining what they do and how they work. But what I want to focus on are these two methods, sort and shuffle. So sorting and shuffling a deck of cards would be useful. And you can see the code that I've used is one line, collections.sort and collections.shuffle. So there's a couple things that we can infer about how I have this written. First of all, collections is capitalized, and I haven't defined anything called collections in this file. So this is a class side method call or a static method call. I'm telling the collections class to do something, and in particular, I'm telling it to sort a deck. And then over here, I'm telling the collections class to do something. I'm telling it to shuffle my deck. Now, I know my deck is an array list of cards, so the fact that I'm not getting an error here tells me that collections are able to sort my deck. Now, we're going to look at something really special in the card class that allows this to happen. But before we do that, let's go peek over at the definition for collections. So here is the collections class, and you can see it has some static variables, and then it has a whole bunch of static methods. So the collections class is not really a thing that you instantiate. You don't make a collection. Really, this is more of a combination or a list of methods that are useful when you do have a collection of something. So for example, sorting is something that you might want to do when you have a collection of something, or shuffling is something you might want to do, or getting the reverse order is something you may want to do, or replacing all the members is something you may want to do. But when you look down at something like sort, you'll notice this other word in here, comparable. And that's going to come into play when we start looking at the card class. So let's go look at the card. All right. Card class is a public class card, but it has this phrase here. It says implements comparable card. Implements. So implements is a reference to using what's called an interface. So the comparable is not a class, it's an interface. So we are making a card that is comparable. Now, before we get into what that really means, let's take a quick look at the card class, and then we'll come back to this and see why that's so important. So first we have some data members, the suit, value, points, display, whether it's black or not, whether it's face up or not. The constructor takes in a value in a suit and then does a little bit of work to get the card set up for you. But there's only one card constructor. There's a method that creates the display. So based on the value and the suit, it'll determine what the card should look like. There's a toString method that says if it's face up, display the card. Otherwise, just display the back of the card. and we're going to skip this method, come back to it in a moment. There's a flip method that just changes whether or not it's face up. And then there's some accessor methods that tell you whether or not it's face up, tell you the suit, tell you the value, tell you the points, and tell you whether or not it's black. Well, we should probably also add a set points method because we did not do that. So let's throw one more method down here at the end. You'll have to do this on your own. So we'll do /**. And we're going to say sets the point value of a card. So after a card is created, it would be nice to be able to say how many points it's worth. So we're going to do that, and we're going to take in a parameter, in points, which is the amount of points a card should be worth. And we'll make our method definition. So we're going to have a public void set points that takes in an int in points, and very simply just says points should be equal to in points. So this allows us to set the value of that data member. So I apologize for not putting that in there. It's a pretty basic method that you would have in a class like this. But let's go back up to this compare to method. And you see there's a big comment here. It says compare to is a method that's inherited by the interface comparable. Really, that's a little bit of a misnomer. It's not really inherited by the interface comparable, but by saying I'm going to use the comparable interface, I'm going to implement the comparable interface, I'm agreeing that my method or my class is going to write this compare to method. So let's take a look real quickly at the comparable interface. So interface comparable, not a class, it's interface comparable. And if we scroll down, you see that there is only one method, the compare to method. And it says, hey, if you are comparable, you should be able to compare yourself to some other object of type T. So a card should be able to compare itself to another card of type T. And down here it gives you some details about how to use the compare to method. But essentially, you're going to say whether something is the same, smaller than you, or bigger than you. And you can return it to indicate that. So a 0 would mean that you are the same, a negative would mean that it's smaller than you, a positive would mean that it's bigger than you. And the value of having this interface is that something like collections does not need to know how to sort cards and sort ages and sort people and sort cars. It just says, I'm going to be able to sort things that are comparable. So this sort method is going to assume the object that is passed in is comparable and then call the compare to method. So I wouldn't be able to organize cards, a deck of cards, if I didn't explain how they were compared to one another. For example, if I have a 5 of hearts and a 5 of clubs, you might say they're equivalent. So we put them right next to each other. But another person might want to say, well, I think cards should be sorted by suit, so hearts should always be considered less than clubs. Similarly, you might say one person might think that aces should be treated as ones and be less than a 2. Other people might think that aces should be treated as the value 14 and greater than a 2. So this compare to method is how you do that. In this case, I just subtracted one value from the other and returned that. I'm not really too concerned about how we compare, just that we compare. So up at the top, card implements the comparable interface, and then I've defined how we compare cards using the compare to method. And because of that, I'm allowed to use a pre-built methods like sort that I didn't have to write. So this is one of the reasons that when we do software design, we really think about what already exists out there, especially in terms of interfaces and whatnot, in order to incorporate that into our work so that we do not need to make things from scratch. I hope this was a nice walkthrough of deck and card and that it clarified how we're using an interface in this program. All right, bye now.